Now you can take a pick here, there's lots of ways of solving this. I'll show you one way with decimals and then we'll do it again using fractions. If we're going to use decimals, a good thing to do before we start would be to change everything to decimals. So that means changing the 16/25ths to a decimal. Now you might want to do this over on the side if you need to, so that you can do your working and then sub that back in. Now the easiest way to change this to a decimal, it's got 25ths on the bottom, so I can easily change that to 100ths. I've multiplied the denominator by 4, so I need to multiply the numerator by 4. 16 fours are 64. So if I've got 64 hundredths, that's 0.64, and then I have this. Okay, at this point, there's a few ways you can go. I'm thinking about getting the A all by itself. Mind you, it's a minus A, so in some ways it might be easy to add A to both sides, which will bring it over here, and subtract these things from this side. It's also sort of tempting to maybe tidy up this before we get going. Straight away I can see though that 0.64 minus 18.2 is nowhere near as easy to do as if I had 18.2 and I was subtracting things away from it, because it's the biggest number that's here. So I'm thinking of rearranging this a little bit to help me get started. So the first thing I'm going to do is add 18.2 to both sides. That'll disappear this minus 18.2. So if I add 18.2 to this side, it'll just appear. I'll still have everything else that was over there. And on this side, I won't have it anymore. I'll just have my 0.64. Now I'm thinking it would be good to add A to both sides so that I can end up with all the numbers over here and the A over this side. So to get rid of minus A here, I can add A, and that'll just give me 18.2 minus 0.5. And over this side, I'll have A plus 0.64. Now at this point, it's kind of tempting to just tidy this side up. I can easily do 18.2 minus 0.5 in my head, or if you needed to, you could work it out over on the side here like this. There's no shame in having an algorithm over the side, just to check that your trading all works out, and you get 17.7. So 17.7 equals A plus 0.64. The last thing to do is to get the A by itself. At the moment it has 0.64 added to it, so if I subtract 0.64 from this side, I need to also subtract it from this side. I kind of like doing this little method of taking it away underneath, because it allows me to actually line up my columns over here so that I can do this like a little algorithm that otherwise would need to have been over on the side. So taking this away here just leaves me with an A on this side. And on this side, I've basically got 17.070, just add a 0 in there as a placeholder. And now I can do my subtraction right here and put the answer straight in, which saves me from having to do it on the side. 0 take away 4 I can't do, so I've got a bit of trading to do, and you can do it straight on your working. And 6 take away 6, line up the decimals, 7 take away 0, and 1 take away nothing. So I've come up with A equals 17.06. Okay, we're going to do the same question now, but this time solve it using fractions. So we've already got one fraction here. First thing to do would be to convert this 0.5 into half. And write down our fraction we already have. And here we've got 18 and 2/10, or 18 and 1/5. Next thing to do would be to change each of these so that we have common denominators. Now we've got halves, 25ths and fifths. So the easiest thing to make is probably 50ths. And if you'd like to do your working perhaps in a different colour with a little bit of cancelling out, then you can write it nice and tidy on the next line. So I'm thinking to convert these to 50ths, I need to multiply by 25, so I need to multiply the top by 25. Here, to convert 25ths to 50ths, I need to multiply by 2 on the bottom, so I need to multiply by 2 on the top. And to convert these, I need to times by 10 on the bottom, so I need to also multiply by 10 on the top. I can then write that line out nice and tidy, and I have minus A minus 25 50ths equals 32 50ths minus 18 and 10 50ths. Okay, next thing I think I might do is add 25 fiftieths to both sides. There's lots of things you could do next, but I'm just picking something. By adding 25 fiftieths, that'll disappear this minus 25 fiftieths from this side, and I'll just have minus a. And if I add 25 fiftieths here, I can very easily add these and get 57 fiftieths minus 18 and 10 fiftieths. Now I've got minus a here, and what I want is a. So the way to convert that is to either think of it as multiplying everything by minus 1 or dividing everything by minus 1. Either way, you can change the sign of everything that's on both sides, but bear in mind that you have two things on this side, one term here and another term here. So if I multiply by minus 1, I will have minus 57 fiftieths and plus 18 and 10 fiftieths. Now don't forget that these two terms could easily be swapped around. It's exactly like saying this minus this. So on the next line when I come to work that out, it might be simpler to think of this as 1 and 7 fiftieths. So if I have 18 and 10 fiftieths minus 1 and 7 fiftieths, then I'm going to have 18 minus 1 is 17, and 10 fiftieths minus 7 fiftieths is 3 fiftieths. And that's a nice simplified fraction, and I'm finished. You might recall that when I solved the same problem with decimals, I got 17.06, and this is 6 hundredths, which is the same as 3 fiftieths, so my answers are actually the same.